And we have here is say this is a skin. Okay. This is a skin. And we can say this is a stiffener, or we can say this is a stringer. Okay, this is a stringer. And there's a damage here. Here was a damage somewhere here. Yeah, there was a damage here before. This area was damaged, and it was cut, replaced with a filler to fill up the gap when you cut out the section, and then you install doubler. Okay. So just pay attention with me, because I will have one good quiz on this later on. That will be quiz number 4. So you can see here, when you have this is a concept design. For you, when you work on the aircraft later on, you don't expect you draw in this manner. So what we do, we draw in the two-dimensional sketch. Okay, what we have here is draw this thing here. Okay. And this is leveler. So we have a pillar somewhere here. Okay, we have 3 fastener. 1, 2, 3. 1, 2, 3. 1, 2, 3. And we have 1, 2, 3. Okay. So you have to draw two-dimensional in this view, and the cross-sectional view, this view has been shown this way. So has been shown here. So what you need to do is you have to have this view, plan view. You don't have to have view from the top. This is not necessary. At least you have front view, and you have the cross-sectional view. Okay. Now let's look at the item one by one. Item number 1, the label. So your label is not like in this table. You can label is here as 1. You can see here is a doubler. Let me make the font smaller. So this is doubler, and you can label also here. This is as filler, and then we can label here on this one here is this is will be the reverse. That's how we label. But For the manual, they will do isometric and they have put the table because they have time for it. For you in the field, you don't have time. That's why it's enough for you just to do the plan view and the cross-sectional view. Most important thing here is for the mechanics to be able to understand the repair and able to install the repair without any error. Okay, let's item number one. Item number one is here is joint section, or we also call it doubler. We call it joint section. And then number two, they call insert, or I call it filler, same thing. Three here is rivets, countersunk, 100°. Number four is universal head. The rivet is still universal head. It's countersunk because it's we need the surface for others. You need the surface. The surface need to be flush. This why countersunk. But here it's not required to be flush. So we install the universal head. Okay, stop there. So for joining section to be determined by reverse engineering method. So here we shall be doing the analysis. So this is what we're trying to do today. So you have to do stress analysis. And here section should be the same. Here is filler or inserts. You can see here is filler. Same thing. And here we can see doubler. Joint section is also okay. Everybody's using the term. So now here same section, same size, same material. Okay, same section and material. Countersunk as per existing. Whatever rivet has been used here before, you use again. And the universal head here on the vertical horizontal flange here is also determined by reverse engineering. Okay. Because here what is already this L angle and the skin is already installed, so they've been using rivet to put them together. So you use the same rivet. So here is a similar rivet. Okay. Similar rivet. Similar rivet as original. Okay. Then we have okay, as far as terminology is concerned, the vertical one here we call it vertical flange, and the one horizontal we call it horizontal flange. So this is vertical flange. And the one that horizontal, the one that we have here is not that one. This one here is horizontal flange because it is in horizontal position. Okay. Enough about that. Detail materials that you use. Now on the repair, there's a note here, structure paint. You have to use a paint. Pre-treatment for painting. Before painting, you use a pre-treatment. Sealants, you have to install sealant. We install the doubler. You install the doubler, install the filler. You have to put in sealants. Remember, I have explained to you about the use of sealants. Cleaning agents for you to clean up the structure paint. So here is all material. As you go to the table, you can refer to. So this is the reference. Okay. material, from material, 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 and material. Paint, paint, cleaning agent, sealants, pretreatment paint, structure paint. So these are all the materials. So when you get this, is from inside the manual. Inside the structure repair manual. So this is a general explanation about the repair concept. Example number 1, we have a form section. Why form section? Because you can see here is radius is very generous. It's not sharp. If we have sharp radius, that is extrusion section. So this is form section, mean that they bend it to make the L shape. To make the L shape, the L shape. Okay. Now this is the note. How you install this? Okay, all parts and fastener install as per. This is the sealants. Wet assembly. Wet assembly means that you have to use the sealants. When you pour in the sealants during installation. Pour mean you brush in, or you whatever you pour or dip the parts into sealants and then you install. Unit material, millimeters, all part to be adjusted. That's why for the structure repair, we don't give dimensions. Okay? All parts should be adjusted. That's why earlier I was explaining to you about the edge distance. So here the edge distance between edge and rivet is what? Is 2D. Okay. Is 2 times diameter. Okay. The distance between the rivets, we set it, we rule of thumb or standard practices, we set it 4 to 6 times diameter. So you have to calculate the dimension from here. Okay, the dimension from here to here. Okay, this dimension using the information here. So from here to here, total length. Okay, you're looking about adjusted. I'm trying to define adjusted. Okay, adjusted. So what you need to do is here you have to calculate yourself. You how many? You have 2D here. You have 2D also from here to here is 2D plus 2D. And then we have 4D. How many? 1, 2. Okay, 1, 2 between 3, 4. Okay, 1, 2. Okay, 1, 2, 3, 4, 5, 6. So plus 6. Say we choose 4D. Plus we have 2D, another 2D here because there's a cut here. It's 2D, 2D, 2D and 2D. We have another 4 times 2D. Okay, this one 6 times 4D. So we choose 4 mm. So 2 times 4 plus 2 times 4 plus 6 time 4 time 4 plus 4 time 2, okay, time 4. So those are the distance. So those are the length. So we got what? We got we got 8 plus 8 plus 16, 6 times 4, 24, 4 times 4, 16, 16 times 6, 6, 3, 96, 96 plus 96, here is 96 plus 8 plus 32. So we total up 16, 96, 32, 144, yeah, 4 millimeter. So it will be 14.4 centimeter. So that is total length of the doubler. So this is doubler total length. So that is mean that to be adjusted, you have to determine yourself. You don't tell the mechanics the actual dimension, but you give this 2D, 4D to them. They will calculate what will be the length of the doubler. Okay, any questions? Now on the material, when you do the drill, you refer to chapter 5114 standard practice. When you do oversize, you happen to do oversize, you refer to 5143.00. Fastener spacing and margin, you refer to 5147. Those are the chapter of the structural repair. For painting, 5123. For sealing, 5124. Countersinking, remember the one in horizontal flange, or the fasteners are countersunk, then you refer to 5146. Stock value, if need be, is not here, not required here when this situation, 59, 41, 49. Then when you do the cut, when you do the bend, the doubler is also formed because you are using a L angle doubler. This angle is formed. It can be formed or can be extrusion. Extrusion, you don't form it. You buy section, L section, you cut. However, if you're working on the form, you have to do the forming because the radius of the forming is more compared to the extrusion. Extrusion radius is very sharp, it's sharper. Then you cannot get those extruded L section fit nicely to the form L section angle. One gauge higher. Okay, the thickness for the doubler for the supplies, or they call here is a joining section. Okay, they call this joining section. Okay, 1 gauge higher. 1 gauge higher. HIGH. What is 1 gauge higher? One ticks up, one more thickness up. 1.4, 1.6, 1.8, 2.0. So it should go high. So here is 1.6. The doubler or the splice section is 1.8. Okay, T24, T42. So that is another rule of thumb. What is another rule of thumb? Similar material. There's two things here. Similar material, 1 gauge higher. for the joining section or for the doublet. So now, as we go again, as what we have learned here, here is stress analysis. So the joining section of the doubler, you should determine by stress analysis. Has been predetermined. But this predetermined has to be checked whether it is okay or not for this thickness. Rule of thumb say 1.8. That's the starting point. However, you need to check whether that 1.8 is sufficient. You may need thicker sections. So, as I have explained to you, you have to get the data. You have to get the engineering information because you want to do the calculations. Okay, what to calculate? You have to calculate what has been lost. You look at here, we have sections. We have loss of sections. And okay, what we have lost here is we lost a section. This is the L angle. Okay. And then what do? We cut off. We cut out the section. So we lost the section. So we lost the section. Okay. So we have lost here. We lost or part of horizontal flange. So we lost part of horizontal flange. What does it mean? Because force equal area, cross-sectional area times stress. So initially we have total force, okay, total load. If we look at here, we have say 20 by 20. Okay. So this is the 20 m, and here is 20 mm. Okay. So the area here is area cross-section area or the part is 20. You have divided by 1000 because the unit must be in meter. Because why? Because the unit that we use, force here is Newton. So Newton meter second. So that area that millimeter has to change to meter. So 20 meter times the thickness earlier is 1.6. 1.6 divided by 1000. You have to transform to meter. Plus, okay, you don't minus. So you have one here, 20 times 1.6 thickness plus 20 minus 1.6 over 1000 time thickness 1.6 over 1000. Everything must be in meter. Okay, 20, the whole thing is 20. 1.6 thickness of this 1.6. And another one vertical flange 20. You minus 1.6 because you start from here. Okay, you start from here because you only use bottom here. So 20, you minus 1.6 here. Minus 1.6. So over 1000, turn into meter. Again, time, the thickness here is still 1.6, 1.6 over 1000. Anyone struggling to follow? If yes, please ask questions.
Sir,
Hmm.
can you please repeat that? I don't understand how to find the area.
Okay, to find the area. I'm looking at the total area. Total area is length time thickness. So this vertical flange is 20 mm and horizontal flange is 20 mm. So 20 by 20 section. Thickness 1.6. So the area, the cross-sectional area is 20. From here to here, 20. Okay. From here to here is 20. 20 mm. Thickness 1.6. So 20 times 1.6. 20, 1.6. And this vertical flange, you already minus 1.6. You only left with, yeah. That's why 20 minus 1.6 thickness here, the time 1.6 the thickness. So that is the total area. Can you follow?
Yes, sir. Yes, sir.
Okay, anyone else? Have this cross section. Again, our L angle is 20 millimeter by 20 millimeter. So we have to calculate the cross sectional area because force, area, time, stress. Okay, area now is 20 over 1000 because you have to convert everything in meter because the engineering unit Newton meter seconds. Time, the thickness is 1.6, 1.6 over 1000 plus we have another section, vertical section, 20 minus 1.6 because that 1.6 has been taken out earlier because you have considered full length here, minus 1.6 over 1000, time thickness again is over 1000. Anyone having problems so far with that? Okay. So what we have 20 over 1000. Okay, I just put it in Excel, it's easier. So area 20 over 1000 times 1.6 thousand plus 20 1.6. Okay. So that's what you get. So 20 over 1000 is 2 to the minus 2 times 1.6 to the minus 3 plus 1.8 10 to the minus 2 times 1.6 to the minus 3. The result will be okay, so 14 10 to the minus 5. So that's the area. This one will be unit meter square. Or we always write it in the way meter with the 2 meter square. Now, what is the force? Stress. So where is the stress? So what you have to look for? You have to look for the FTU, FTY. Okay. We look at the original first, FTU, FTY. But like I have explained earlier, who has followed my class, we have to decide either FTU or 1.5 times FTY. Why? So what is the reason? The reason is this. So this is the where we fail, that is FTU. Okay. Somewhere before you fail, you have FTY. This is mechanized material. Who are not able to complete to have not taken FTY MOM or you fail MOM, you'll be struggling to on this subject. So please bear in mind, who are not doing well in MIM, please go back to MIM because everything is from there. Okay, now, why? Because we do not want, if you have multiply 1.5, so in this situation, the FTU is 390. Okay, this is 390. Megapascal, MPa. Pascal is Newton meter square. And FTY is 230. 230 megapascal. And then if you got 1.5 times FTY, you got 345. So here is here is 1.5 times FTY equal 345 megapascal. So we have to decide minimum of FTU or 1.5 times FTY. So the minimum here, 1.5 times FTY is 345, FTU is 390. Okay. So you choose the minimum, which is 345. Always, this is always been, you always remember this. When you do analysis, always start with this. Don't forget. You must start to identify the loads by determining FU or determining the minimum of FTU or 1.5 FTY. Okay, don't memorize this. Reason why? If you multiply what 230, you got 2345, means below 390. So this is very used. You don't go 390 because this region, as you learn in mechanics of material, this region is already plastic. This region, we call it plastic. Plastic region, material has been permanently deformed, which is not acceptable for aircraft. So you have to use the minima. So the minima is 345. So the forces, the load that go through the section will be area, 6. Area is 6. Sorry. Load of force that go through. Go through. Okay. Go through the L then equal 6.14. 10 to the minus 10 to minus E minus 5 time with that area meter square time 3, 4, 4, 5 Pascal. So this is how much the L section would take up. Anyone help me to calculate? Give me the number. Are you guys sleeping or what? Are you following or not?
Yes, yes, sir.
Yes, sir, we are.
Yes, sir.
Kalau tidur rugi oh. Ini adalah peluang kerja. Jadi 3, 4, 5. 1, 2, 3. 1, 2, 3. Okay. It's 21183 Newton equivalent to 21 kilo Newton. So this is the total force that this L angle can take. Okay, back to the selection. How do we get the 390 FTU FTY 230? You go to table numbers 2, okay, or the manual. How to look at this? You have to look at material 20242. Okay, 20, 24, 42 clad. 20, 24, 42 clad. Thickness 1.6. 1.6 is somewhere here. Okay. Where is it? Okay, somewhere here. FTU is 390. FTY is 230. Okay. So, okay. So remember again, to be conservative, like I said last week, LT. We use LT. LT is the grain direction of the material. And then you always use A. A is more conservative than B. So FTU LT 390. You can see here 390. FTY is 230. You can see here is 230. And then you multiply. You have to choose either the minima of FTU or 1.5 times FTY. So don't do the quiz yet. I wrongly set up the quiz. Do not attempt the quiz. Okay. Anyone clear about this? Where to get the value? Then FCY is 235. Okay. FCY is 235. Still use LTA. And then FBRU. FBRU is FSU is 220. FSU 220. And then you look for FBRU 560. Okay, each distance 2D. Yeah. Then what are E? Modulus of elasticity. Okay, we use elasticity. It's always here. So remember, all this for mechanics material. If you fail, you are able to. If you are not able to do mechanics material, if you have not done mechanics material, I don't know how you're gonna get through this. Okay, never mind. Okay, now this is a value. You have to go to the table, take the value, and this value will be used later. And the value for here is we use for, okay, to check the net tension failure of the tablet. And FCY for you to check the, we don't use FCY a lot. FSU, we don't use, we use FSU for the, to check the shear failure. And we use FBRU to check the bearing failure, to calculate the bearing failure. Okay, so that's why we need all this value, because we have to do further analysis on this. Okay, now we determine, we have the understanding what is the whole section capable to take. But we got problem here. Our problem is we have lost the area. We have lost part of this. So what is lost? Now you have to calculate the loss. So area loss. Loss area. Because you cut. Remember you cut? It will be, because the cut is only here. Okay. You cut off this off. So the loss area will be 20 minus 1.6, because the vertical flange thickness is 1.6. Okay. Over, easier put it this way, 1000. Because you have to change to meter. Then we got meter here. Minus, okay, minus, okay, time, sorry. Time, thickness, 1.6 millimeter, or again 1000. This one is meter. So what do you get? 20 minus 1.6. I'm working alone now. Divided by 1000. Okay. 0.0184 meter times 0.6 over 1000. 1.6 1000 0.0016 meter. You get
2.944, sir.
0.0184, huh?
2.944.
2.944, and to the minus
10 times 10 to the power of 5, negative 5.
Okay, 5 meter square. Okay, meter square. Okay, loss. This is loss. So when we have lost the area, mean that you have also lost the load. You lost load capability because you do not have the area anymore, which is equal to how? So 3, 4, 5, same. This is stress time area loss, which is 345 megapascal 2.944 E minus 5, which is equal to what?
10 kilonewton.
10 kilonewton.
Yes, sir.
10 kilonewton.
Kilo SS.
So you have lost that. So you need to recover the loss. How? That's why you put in the doubler. Okay. So this vertical. So we have lost here. That's why you put in a doubler. Okay, but you don't just put it over here, it will be a gap around here. So that's why you put it as an L. Okay. An L doubler. And then you install reverse. You install revert to tie them together. Basically to transfer the load. So here will be the filler, or in Airbus they call it insets. Okay, here is the insets. Insets or filler. Same thing, English. And here on top here we call it doubler. Okay. We call it doubler. So now you know already the original is 1.6. And then the doubler is 1.8. And then you need to determine the value of 1.6 and 1.8. So 1.8 is somewhere here in this region. And then you put in the table. That's why also you got this doubler FTU, FTY. FCY. So this value changed because if you look at the table, the thickness changed. Now is you have to go to this column. Still use the same concept, which is you use A value to be conservative, and always go for the LT. Okay. LT. So why? Why is LT? Like I was telling you earlier, all the sheet metal come in a roll when you open up, okay, this direction is L. This direction is LT. But during the fabrication of the doubler, you do not know either the cut to L or the cut to LT. So to be conservative, we consider the cut to the LT. The L is direction, the grain direction in this direction. That's why it's stronger. But you cut across, it will be weaker because the grain can be separated, easily separated, rather than following the grain. That's why we refer to LT, because we do not know where they cut to the direction, unless you tell them cut to L. And in fact, when you unroll this plate and you see the plate by itself, it's very difficult for you to determine which is L direction, which is LT direction. Okay, next is what to be done is you want to determine the doubler. What is the doubler strength when you put the doubler? How much do you get? So load restore or load or doubler. Load the doubler can take still stress time cross sectional area. Okay, stress is now you have determined based on the table. Is 352.5. Okay, 3.2. Where is it? I lost it. Okay.
352, sir.
Recover. 352.
Yes, 352.2.
Mega Pascal. The area now is the area now is 20 still minus 1.6, the original length. This length here over 1000. Okay. Now you have to multiply by 1.8 because the thickness now is 1.8. The double thickness. What do you get? What do you get? You guys following or not? You're not helping me to calculate. This is listening only.
Calculating, sir.
So what do you get?
11.67 kilometer.
What do you see? You see you lost 10, you're putting in 11.67. So seem to be you putting at you recover in fact you improve the strength, because earlier you lost only 10, but now by putting a doubler 1.8 thickness, you now having 11.67, which is seem to be good. Then the rule of thumb, one gauge higher, seem to be working. However, there is a certification requirement for the repair to be acceptable. The factor of safety must be 1.5. So you divide by 11.67, divide by 10, you get only 1.167. Can you certify that?
No, sir.
No, because requirement is 1.5. Your repair now 1.167. What you need to do? You need to increase to the next thickness. If you put 2, what do you get? Anyone help me? This is, if you put 2 millimeter thick.
Get 12.96 kilonewton.
So, fatal safety 12.96
Kilonewton.
kilonewton divided by 10 kilonewton. Still not good because 1.2. So what thickness is required for you to get 1.5? So now the problem is become the doubler become thicker. So what's the problem? You will introduce bending to the fastener. So this is 2 plate, very thick plate, and you try to put the fastener here. Okay, when you have to put the fastener there, when you put the force, okay, apply the force and apply the force here. You create bending. So you create bending to the fastener. The fastener does not like bending. Okay, create bending reverse. So they don't like it mean it will fail. So the fastener revert is to carry reverse carry shear load, not bending load. So what is the next? When become doubler, become thick, you have to find alternate material. So no longer aluminium, you go for AISI, stainless steel plate. That's why the maintenance manual also list out the alternate material. If the doubler become very thick, you will use stainless steel. Okay, anyone with problem so far? Because you may need to go back and think about it again. So I'll stop here and then I will start the quiz, not your quiz. I'll give the chance for those who came in late to this class because for some reason they just transfer in this class, or for some reason I'm not sure why and what. I will open up the quizzes and you have to attempt them all, and because I have to submit the score by the end of the month. If not, then you will be barred. So please do so as soon as possible. I will open up. For the rest, please look at this again, and over the weekend I will throw in you a quiz. I will let you know when. Over the weekend or early next week.
Alright, sir.
Okay?
Sir, nak
Yes.
tanya boleh sir?
Boleh?
Yang sir kata tadi pasal alternate material untuk doubler, so tak ada dissimilar metal corrosion lah?
That's why for the alternate material, bila you letak ASI 301 stainless steel, you have to send the material for cat plating. You have to protect the surface by cadmium plating. Dia jadi mahal lah repair you. But we have no choice because we become thick and thick. To satisfy the requirement 1.5, the material become very thick. Then when become very thick, you have to replace with the stainless steel, because stainless steel stress is so it can take up higher load at the thinner on the thinner plate. For dissimilar metal, betul. It's very good question. It's true. You will have dissimilar material, and then you have to treat that stainless steel by doing cadmium plating. You have to cadmium plate the stainless steel part. That's why it becomes expensive. This is not something that you always do. You only do it when you do not have any choice. This is in the manual. The manual will list also the stainless steel as the alternate alternative to aluminium in doing the double repair. Good question. Any more questions?
So basically, by replacing alternate material, so the stress is increased, sir.
Not the stress is increased.
What I mean is the load
because,
capability.
yeah, because the FTU, okay, FTY 345 megapascal. Stainless steel can go to 7 or 800. Yeah?
Alright.
So you replace this to 7 or 800, and then you get huge load capability.
Alright, understand.
Yeah? Okay. Anyone else? Good questions? So those question will be in your midterm. We'll do midterm immediately after the midterm break, and then we'll proceed with the assignments. Assignment will be a question you have to. Oh yes, Mushahira.
I just wondering, do we have practical for this subject? Because
You should have. However, most of you, some of you stay at home. But in our SLT, there's no practical. Okay, no requirement for practical in the SLT. So you're safe just to stay at home going to the course.
Alright, Prof.
Because this is basically this course is stress analysis course. The hands-on is doing the stressing on the repair. The one I'm telling you, those are the hands-on. Those are the practical. Basically, I'm doing the practical to you. Engineering analysis practical. This is engineering. This is not memorizing class. This is engineering. You have to put up all your knowledge in your static, dynamic, mechanics of material, and then your practical hands-on before in SEM 3, you're doing structure repair as well. You put together in here. We design the repair, we analyze the repair, and we develop the repair procedure, and we go through the process to get it approved from the authority, and then this repair can be embodied to the aircraft. This is real. This is real activity. This is what has been done out there. This is what people been doing out there at the airline, at the MRO, and also designing the aircraft. I have designing 2 aircraft. I involve 3 or 4 aircraft design. So I'm not teaching you from the book here. I'm teaching from you. I'm teaching you on what I have done before in industry. But still doing it for some company. I'm still doing the consultation for them, doing the stress analysis. Okay, clear? No Shahira?
Yes, Prof.
Okay.
Just because this one, if it will be for me, I would like how to say, I will be more understand if you have practical session.
Yeah, it's no. The practical will be you just sit in front of me. I'm doing thing on the board. There's a practical. Here is like talking to, just like talking to the ghost lah. I'm hearing you, you hearing me, and then I don't see your face, you don't see my face. I'm sitting here in my bedroom, then a corner of my bedroom, that's my office. It's very it's very tiring for me as well, and very it's really I've been doing. Luckily, the last semester all done just like this. They all, I don't know how they managed to get through. The last semester, never seen them. They never see me also, but they managed to get through. Alhamdulillah. But for you here, that's why you have to keep up with the knowledge here, and I'm throwing you the quizzes, and then anything you let me know if you have problem. Okay, no Shaira, you want to be technical service engineer, isn't it?
Hopefully.
Okay, good. It's a good job because you'll be there. I mean, this is the most safest airline job. One of it. Okay, any more?
Sir,
Yeah.
I have a question. Regarding the thickness of the doubler,
Mm.
is there any maximum gauge thickness before we consider it as too thick?
Okay, that's why I have not shown you. I'm not going through that yet. However, yes, the limitation is here on the fastener. You can see here, if you're 1.8, 0.8 mm, no fastener. I mean, you cannot use. So 1.6, you use AD rivets and no other rivet. So here is the limitation. Yeah. Thickness of the plate, 4 mm, no more rivets, only DD rivet. So you're going to go to what? 6, 7? How are you going to go to this? Because no more rivet. This is rivet size. This is a rivet selection. Your thickness, this is a rivet. This thickness, this is a rivet. Until 4.0, no rivet. You have to go for quarter-inch rivet. Okay, quarter-inch rivet. Can you fit into the small flange quarter-inch rivets? Cannot. Become very thick. Become very big. The rivets very big. You have to cut big hole. So that is the limitation. Limitation is when you go through this table here to choose the rivets, you can see the limitation is here. Become too thick, is no rivet selection. You cannot use 4mm rivet, 316 rivet. Standard rivet is 4mm. You cannot use a standard 4mm rivet more than 3.2. Am I answering questions?
Yes, sir.
Okay. It's easy, everything in the table. Whatever aircraft you deal with is everything in the table. Boeing, Airbus, whatever you tell me what aircraft, they have structure repair manual. The structure repair manual will have all this information. What you need to know is try to understand where to find the information and what is the basic calculation of the load, which is load is force times area, stress is force over area. That's all. And it's given also. For Airbus, the structure repair manual, all the formula is given, and all the methodology, how to do the calculation, also given. For all model, I've checked the manuals for all model, they're all the same. Whatever you see here, you can see for 380, 350, 320, A400M, the Air Force is being flying now. They have the same concept, same philosophy, same pages of the information, only a different manual. Okay, you may see this example repair on all the Airbus series. Okay, any more information? Any more questions? If not, I stop here. I open up the quiz for the rest who have not done the quiz. Okay. Thank you. Assalamualaikum.
Waalaikumsalam, sir. Thank you, sir.
Thank you, sir. Waalaikumsalam.
Thank you, Prof.
Thank you, Prof.